Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're going to go ahead and begin to work with complex numbers. Now, when we are solving over the complex number system, we're going to be introducing a new number. That number is called I. All right, I happens when we're going to go ahead and we're going to take the square root of -1. So when we have something like x squared is equal to -1, we know that to undo a square, we get x to be equal to plus or minus the square root of -1. And up until now, you've been told that you can't take the square root of a negative number. But here's the thing, you can. You can take the square root of a negative number. You just get an imaginary number instead. So we're going to introduce that the square root of -1 is going to be equal to I. I stands for our imaginary number. So when we've got x to be equal to plus or minus the square root of -1, we can now go ahead and say x is going to be equal to plus or minus I. All right, so key concept here, the square root of -1 is replaced with I. Everything else is done the exact same thing. You just go ahead, you tuck I in as part of your answer. Speaking of our answers, I want to go over how we write our answer in proper form. We touched on this a little bit yesterday with the rational and then plus or minus the irrational. Your rational part will always go ahead and come first. So something like 3 plus or minus the square root of 7. It is always the nice looking number and then the messy looking number. The rational plus the irrational. We do the exact same things with the real and the imaginary as well. A real part and then plus or minus whatever our imaginary part might be. 5 plus or minus 2i root 3. Now also take a look where the I is located. The I comes right before the radical sign. All right, so if we go ahead and we take a look at some of these here, if I give you 2x squared plus 26 is equal to a -10, and I want us to be able to go ahead and to solve this over the complex number system. I can subtract the 26 and I'll get 2x squared is going to be equal to -36. And then I can divide by 2 and I'll get x squared is equal to -18. Now when we take the square root, we're going to have the square root of -18. So going ahead and simplifying that, I know I'm still going to have my plus or minus. And then if I just think about an 18 for a moment, all right, 18 breaks down into 9 and 2, and the square root of 9 is going to give me 3. And then I have the square root of 2. But notice I also have that negative sign in there. We just saw that the square root of -1 is going to be I. So we read this as plus or minus 3i times the square root of 2. All right, let's take a look at number 2. Again, I want to be able to isolate that squared term. So I'm going to see that this is 9 times w minus 4 squared is going to be equal to a -1. And then I can go ahead and divide both sides by 9. That's going to give me w minus 4 squared is equal to -1/9. And now I know I need to go ahead and take the square root of both sides. So I'm going to have w minus 4 is equal to plus or minus. Let's talk about that square root of the square root of 1/9 first. Well, the square root of 1 is 1. The square root of 9 is 3, so I have 1/3. And the fact that there's going to be a square root of a negative number, I can go ahead and put the I right next door. I then want the w all by itself. So I'm going to write this as w is equal to 4 plus or minus 1/3 times I. Now another way that you may go ahead and see this, you may see it as 4 plus or minus I over 3. It means the exact same thing, just so we know, okay? Whether it is a 1/3 I or an I over root 3. All right, now with our complex number system, we have real parts and we have imaginary parts. And we're going to work with dealing with some operations on them. All right, if we think about adding and subtracting is just like combining like terms. We're going to add the real parts and we're going to add the imaginary parts. So if I look at this first one, 3 plus 4i plus 2 minus 7i, I'm going to add together the real parts. 3 plus 2 will give me 5. And then 4i minus 7i is going to give me a minus 3i. I have 5 minus 3i. Similar with subtraction, we're going to subtract the real and the imaginary parts. I'm going to first go ahead and make sure that I distribute that negative sign there. So I'm going to see that this is minus 8 and then plus 2i. Well, 6 minus 8 is going to give me negative 2. And then negative 4i plus 2i is going to give me a minus 2i. All right, so when we're adding and subtracting is just like combining like terms. Now when we get to multiplying, here's something I want you to think about. When we multiply imaginary numbers, an I times an I, we get an I squared. Well, I was equal to the square root of negative 1. So when I do the square root of negative 1 times the square root of negative 1, those square roots just cancel each other out, which leaves me with just a negative 1. Therefore, what we're going to go ahead and see here is that I squared is always going to be equal to just a negative 1. So if I'm looking at number 5 here, I want to go ahead, I want to distribute 3i times 4, I'll get 12i. 3i times a negative 7i, I'm going to get a negative 21i squared. Well, if I do 12i, I squared is the same thing as saying negative 1. So negative 21 times a negative 1 is going to give me a positive 21. Writing this in standard form though, the real part comes first. I have 21 plus 12i. Let's go ahead, let's take a look at number 6. Again, I want to distribute. 2i times 3 is going to give me a negative 6i. Negative 2i times 5i is going to give me a negative 10i squared. So this is negative 6i, and then a negative 10i squared, that's a negative 10 times a negative 1, which gives me a positive 10. Writing that in standard form, that's 10 minus 6i then. All right, so we dealt with distributing. Now let's go ahead, let's think about foiling. All right, when we go ahead and we FOIL, the first numbers, 3 times 4 will give me 12. The outside, 3 times negative 5i is going to give me negative 15i. The inside, 2i times 4 is going to give me a plus 8i. And then the last, 2i times negative 5i is going to give me a negative 10i squared. A negative 10i squared, that's negative 10 times negative 1, which is going to give me a positive 10. Again, this guy right here, this was a negative 10i squared. Now we can go ahead, we can combine like terms. 12 and 10 together gives me 22. And then negative 15i plus 8i, that's going to be minus 7i. All right, notice all of this went ahead and simplified down again to a real part and an imaginary part. Now let's take a look at number 8. Number 8, again, I want to go ahead and I want to FOIL. Well, 4 times 4 is going to give me 16. The outside is a negative 20i. The inside is a positive 20i. And then that last 5i times negative 5i is negative 25i squared. A negative 25 times a negative 1 gives me a positive 25. Now take a look at these middle two terms here. Notice that these guys, they're going to go ahead, they're going to cancel, aren't they? That imaginary part is dropping out. 16 plus 25 is going to go ahead and give me 41. This 41, this is a pure real number here. There's no imaginary parts. All right. Now notice here, I had the 4 and the 4 to begin with. I had the 5i and the 5i to begin with. The only thing that was different was the plus and the minus. This right here is an example of what we call a complex conjugate. Complex conjugates are important to us because they're going to go ahead, they're going to help us get rid of imaginary numbers. They're going to help us get rid of square roots of negative numbers and makes it a pure real number. So this becomes helpful to us when we get into division. If I have 4i divided by 5 plus I can't just go ahead and cancel out those i's. All right, my stopper on that is my plus sign. I also can't just multiply top and bottom by I because it's going to make it a little bit more messy. So instead what we're going to do is we're going to multiply by the complex conjugate in the denominator. 5 plus I, which means my conjugate is going to be 5 minus I. So I'm going to multiply top and bottom by 5 minus I. And when I do that, 4i times 5 is going to give me 20i. 4i times negative I is going to give me a negative 4i squared. That is a negative 4, which turns into a positive 4. And then downstairs, 5 times 5 is going to give me 25. The outside, again, is going to be a negative 5i. The inside is going to be a positive 5i. Those will cancel out. That's the whole point of doing it. And then the last, I times negative I, well, that's a negative I squared. That's a negative 1, which is going to give me a positive 1. So if I want to go ahead and rewrite this, this is 4 plus 20i divided by 26. Now, here's the thing. I need to go ahead and simplify. I'm going to simplify the real part. I'm going to simplify the imaginary part. Both of those parts get put over 26. So I have 4 over 26, which will reduce to 2 over 13, plus 20i over 26, which will reduce to 10i over 13. You can leave it just like this. Sometimes, however, you may see it written as 2 plus 10i over 13. You should be able to recognize that both of those are the same. All right, let's see if we can do the same thing with number 10. Again, I cannot just cancel out the i's. Instead, what I need to do is multiply top and bottom by that complex conjugate by 2 plus 3i. Upstairs, we're going to FOIL. 6 times 2 is going to give me 12. The outside is going to give me 18i. The inside is going to give me 10i. And then the last, 5i times 3i, well, that's going to give me a 15i squared. So 15 times negative 1 is a negative 15. Downstairs, 2 times 2 is going to give me 4. The outside is going to give me a 6i. The inside is going to give me a negative 6i. Again, those are going to cancel out. That's the whole point of this. And then downstairs, negative 3i times positive 3i. Well, that's going to give me a negative 9i squared, which is a plus 9. Now, if we go ahead and we clean this up, 12 minus 15 is going to give me negative 3. And then I have 18i and 10i, which will give me 28i. And downstairs, I'll have a 13. Now, if I try to simplify, negative 3 over 13 does not simplify. 28i over 13 does not simplify. So I can go ahead, I can leave my final answer just like this. All right, so keep in mind again, when we are taking the square root of a negative number, the square root of negative 1 is going to be equal to I. And if I have an I times an I, which is an I squared is just equal to negative 1. So Del Zadi is done for today. I will see you in class.